Hey guys, welcome to a solid edition of this tutorial series. Solid because we are going to understand the fundamentals of the much talked about solid principles in objective-oriented programming. In the grocery app project which we are building, as part of the long run tutorial series, I have tried to make it as much solid as possible. In the sense, the whole architecture is flexible and maintainable. That's the whole intention of applying solid principles to make your projects understandable, flexible, and maintainable. The theory of solid principles was proposed or introduced by Robert C. Martin, famously known as the Uncle Bob, who also proposed the clean architecture, which we call as the Viper architecture, in his paper Design Principles and Patterns. Also, the solid acronym was introduced later by Michael Feathers. That's kind of the explanation about solid, but let's get into some implementation of solid in iOS Swift. So let's get started. So what does solid principles stand for? S for single responsibility principle, O for open close principle, L for Liskov substitution principle, I, the interface segregation principle, and D, dependency inversion principle. Not the dependency injection, but dependency inversion principle. So these are the five principles which are very much required for building a flexible and maintainable architecture. So let's start with understanding each and every one single by. Let's start with the solid single responsibility principle. So in my application, I have an implementation. I'm just showing an example of where it is being implemented in the application called grocery application. If you don't know about this project, you'll have to go to some of my previous tutorials, which is like some 15-20 episodes are already there. You'll have to refer that to understand what this code base is. Otherwise, if you are already following it, then it's easier for you to understand what I'm trying to say. So let's start with the first principle called single responsibility principle. So I can show you one case where it is being applied in the project where I have an auth interactor. So what does a single responsibility principle say? One of the first solid principles. So in my case, an interactor needs to just do one job at a time. It should not handle multiple responsibilities at a point in time. Let's say if in my scenario, let's say this is a login scenario, if I had to do both requesting for a login using Alamofire and getting a token back from the server, and let's say if my interactor had to also save that token using Realm database, everything happening at the same place within this, let's say, auth interactor file, then it has to do a lot of things. Let's say I am a freelancer. If I had to do, I am supposed to do a lot of things myself, like let's say my accounting, programming, then client interfacing. Lots of things are being handled by myself. So it becomes stressful for me. So if I have to delegate it to a responsible person, let's say if they have to do their own job, like my accounting guy has to do only accounting job, then if I'm delegating it to him, then it's easier to maintain my work that way, so that I just concentrate on whatever my responsibilities. Let's say it might be just programming. So that is the whole intention of introducing something like a single responsibility principle. So in this case, at least in my case, whatever is happening is if the interactor is actually requiring a login feature to be implemented, then it is taking the help of a couple of other things. Let's say login is happening through an API interface exposed outside through an auth API, which is nothing but a protocol, and this protocol is being implemented in my project by a service layer. So that service layer takes care of requesting for a login using the email and password, and it returns a token back to me, let's say to the interactive side, and then it becomes the responsibility of the database which I have created to store that token. So I'm delegating these work to those individual respective owners of that work, so it becomes easier to maintain and manage my modules. So this is the basic principle behind a single responsibility, which is being implemented in this case. So you will see these kind of implementations, single responsibility implementation, all across this project. So this is one of the scenarios where let's say an interactor has a specific job to do, and it is delegating its work to individual components which does its own job separately. So that is single responsibility principle. Let's now go to the second one, which is open close principle. Very important. So whatever it says is software entities like class, modules, functions, etc. should be open for extension but closed for modification. It's a simple case where if your class is doing, if your class is doing so much, if it has so much of business logic embedded, a classic case being our view controllers in iOS, if you don't actually segregate our business logic separately, then we are including lots of logic, or we are embedding most of the changes which needs to happen within this view controller. So it becomes very difficult to maintain it at a later point. So one of the things that we can do is keep our modules easy to extend and close it for changes. An example here being I have a control called account text control. If I can just show that by running the application. So this is what I'm talking about. These two controls, email and password, these are two controls created using something called as an account text control. So what happens is whenever I try to log in, it gives me some kind of errors. So at least in this case, now it is giving me a required error. As soon as I type something, it'll give me an invalid error. And something like this, and that error is gone because I have something valid given already. And this has started giving me something called as field length error. It has to match between 6 and 12. So I am introducing different kinds of validation rules for this control from external through something called as a rules array. So if I had actually implemented whole of this rule within the same control called account text control, then it would have been a nightmare later if I had to introduce some more new rules within this control. So it would have gone for lots of changes, and if I had to reuse it later in a different project, I will have to carry each and every rule along with this control, where it might not be valid or applicable for that specific use case. So at least in this case, I am passing these rules from outside. These rules are nothing but I have defined it externally using something called as a field validatable. So which is something which this control will implement, and that control can start accepting these different rules which I have defined. So everything is conforming to something called a protocol called rule, and every rule is implementing that. So a required rule implements a rule, and then I define what is the validation that needs to happen to this control. So if it is empty, then it's not a valid rule. So you return this message saying your field is empty, you need to show this error message to the user. Similarly, let's say if it is a message length rule, then even there I'm checking within the validation rules, I'm checking whether this is satisfying a minimum length criteria. So I can have these kind of different rules passed to this. Let's say a password rule which showed me like it should be between 6 and 12. So there I have something called I have a pattern being sent as a regex, and then I'm using that to validate that rule. So each and every rule is coming from external source instead of embedding that within my control, which is this control. one more back. Yes, the account text control is not actually holding those rules, but it is being injected from external. So this becomes easier to extend my control, and I'm not modifying anything within this. So whatever is the definition of single solid open close principle is, software entity should be open for extension, which is happening here. I'm extending the rules externally, but I'm closing for modification. I'm not doing any kind of changes within this control to include a new rule. So as soon as a new rule is added to this array, it will get validated along with this. So that's what open close principle is all about. So let's go to the third rule, which more will feel like an academic rule, which is Liskov substitution principle. So it's also called as design by protocol, which us iOS Swift, at least the Swift developers, are accustomed to a great extent, because most of us do build application based on protocols. So we define the protocol and start building the features on top of that protocol. That's how we build it. So pretty much whatever is expected by Liskov substitution principle is being taken care if you are using a protocol. So what does it say? Objects in the program should be replaceable with instances of their subtype without altering the correctness of that program. It's all technical, where it feels like more academic, where you're saying you have a superclass and it does a certain kind of job with its own validations, and if you are including a subclass and this and you are inheriting from this base class, if you are using this subclass somewhere else, it should behave very similar to how a superclass is behaving. So that's the technical side of it, where the principle says like that. So it because we might end up using inheritance in a bad way, this rule will be totally violated. So one of the reasons that each and every architect or somebody who is a matured programmer, who understands the problems of using, let's say, inheritance, tends to tell you that don't overuse inheritance. Instead, go with a protocol or an interface in any other languages. So that's why it's a very good pattern that we implement everything using protocols. So let me explain what I meant by this. So I have a function called fetch groceries using two things. One is I have a real service, which is a grocery service, which has a function called fetch groceries. It has a specific implementation where I request to the server and it gives me a response in a specific format, which is this format. So each and every validation, whatever I have applied within this, works in a specific way. Let's say I also have something called as a stub server, which is very much local to this, where the groceries are coming from a JSON file called products. So whatever I do is I just use this products.json file and get that data locally, and then just send it back in a similar fashion, like however it is happening, let's say in this case. So both of them does the same thing, just that it is conforming to a protocol. It's called groceries API. So fetch groceries, let's say this is my fetch groceries. Fetch groceries of grocery API works both using grocery service and stub service. I have used both grocery service and stub service. So the consumer of the groceries API protocol, so whatever I am exposing to, let's say this is being sent to an interactor, both these services. Let's say if I don't have an internet and I want to test this application, I will use the stub server, which is more like a local database server. And if I have an internet connection, then I'll really use the grocery service, which is actually connecting to my server and getting those data. So as a consumer, let's say if this data is required by my interactor, it does not care where this data is coming from. It's only looking for the correctness of that data. So it is happening through my stub service or a grocery service, but both being exposed through my API, which is a protocol. So that's what this groceries API is, what my groceries interactor, let me just show you that. Groceries interactor is only accepting the groceries interactor is accepting the API through this protocol instead of the real the classes or the objects which are having the implementation. So I'm just exposing my interactor through this protocol. So that's the whole idea. So my interactor does not really bother about where this data is coming from. So that's the idea behind this principle. If you are actually deviating from this principle, then you are going to have an implementation which will be erroneous. So if you are programming using a protocol, design by protocol is the best way where you can avoid these kind of issues. So that's why that's the whole intention of this principle. Objects in a program should be replaceable with instances of their subtypes. At least in this case, subtype is our protocol. That's what we are exposing to our interactor. So without altering the correctness of that program. So with that protocol, whatever you are passing to that interactor, if my service is conforming to my protocol, in this case it is groceries API protocol, then I don't need to worry about its correctness, because it's going to always behave in that same fashion for any case. So that's the basic idea behind this principle, Liskov substitution principle. Hope that is clear to you. Let's go to the fourth principle, which is one of my favorite principles, which is called the interface segregation principle. So iOS developers have been a victim of having huge view controllers. So that's one of the big fat view controllers are one of the curses because of the architecture that we are given called MVC. We tend to write everything in one file. Similarly, if you are creating, let's say, a feature, at least in this case, my case, let me just give you what this principle is all about. Clients should not be forced to depend upon interfaces that they do not use. Simple as let's say I have created a big database which does different kinds of job. Let's say if it's used to save your authentication, authorization, responses. It also does save your shopping cart. If it saves your grocery items, let's say locally, everything if it does, then if I am just exposing that database through one interface having all the function, let's say in this case I have, instead of the auth db, if I had something called as my grocery app db, which at least in this case, let me just show you what I meant. So I have this database. If I had something, all of this, if I had included even in this auth db and just called it as grocery db, a big one, grocery app db, a big interface, then I am having everything in one place. Let's say save token, save user, get card items, update cart, delete, get count, all of this is coming to one big interface. What happens is, let's say one of my consumer, which is like a cart interactor, needs just maybe I'll just go to auth interactor. So auth interactor might be just needing whatever functions are required for authentic authorization and then just saving to the, let's say I have save token function. That's the only thing this interactor might be requiring. But unnecessarily, if I had everything here, then I am exposing each and every function which are even not even needed for that specific use case. So whatever we do for that is we separate out features based on protocols. So whatever is required for AuthDB is just there within AuthDB. Let's say if I have something for card section, I have it only within this card DB. So whoever is consuming it, let's say one example here is this card interactor requires some features from AuthDB and some from CardDB. In that case, I can just pass it like this, combine both of the interfaces, but ultimately you'll just pass the whole database, which is actually implementing each and every interface here. Let's say realm database is what I have, and it is implementing CardDB, AuthDB, and every DB which is required. But I'm only exposing my database to different layers like the interactor through these different protocols which I have defined. So that's the idea behind this rule, interface segregation principles, where client should not be forced to depend upon interfaces that they don't use. So that's the idea here. I hope this is clear. You are segregating or separating your features into smaller into smaller protocols, and then just implementing it whenever you need it and exposing the features through that protocol to different layers which you are using, let's say which is your interactor or something. So that's the idea behind this fourth solid principle, interface segregation principle. And finally, the fifth one, dependency inversion principle. Don't confuse it with dependency injection principle, which is something different. This is dependency inversion principle. So what does it say? A high-level module should not depend upon lower-level modules. Both should depend upon abstractions. Abstractions, again, it is pointing towards protocols. Abstractions should not depend upon details. Details should depend upon abstractions. Technically, it's nothing but whatever we even explained in the previous interface segregation. Even I explained whatever this is, where you are just passing the protocols dependencies instead of the whole big bunch of objects or the class objects which you are created. Excuse me. So instead of that, you are just depending only on the protocols to expose different layers. A simple example here being a groceries list view controller has a reference to its presenter through a protocol named grocery list presentation, which is just an abstraction of protocol. Similarly, grocery list presenter knows about grocery list view controller through something called as a grocery list view here. That's another protocol, which is again a protocol. So this way, we are not tightly coupling our modules and making it reusable. So let me just give you that, whatever I meant here. So my groceries list view controller in this Viper architecture is having an instance of a presenter, which actually does different jobs for the view controller. So I'm not exposing directly the presenter through using the direct presenter object, the fat object. Instead, I'm relying on a protocol. So this protocol is being implemented by my presenter. So my view controller only knows about this presenter through this protocol. Similarly, if I go to my presenter needs to update my view. Maybe if it gets an error or a success response, or if it gets some data, it has to send it back to the view controller. But for that, we should not depend. You should not add a dependency of the view controller directly to your presenter. That will lead to a bad architecture. you cannot have a view controller, then there is no point of having a wiper architecture or a clean architecture in that sake, in that instance. So however we do that is we again have a protocol which is implemented by this groceries list view controller here. So whenever we need to update our view, all that we need to do is to use that view, let's say something like this, and call the functions, which will in turn will trigger a function in your view controller which is implemented there. So that's how you create a dependency inversion through protocols. Again, everything is through protocols. So all of these design principles pretty much works using protocols in Swift. So hope this is also clear. Excuse me. The dependency inversion principle, where we are only depending on the abstractions and not on the details. Details in the sense like view controller is a huge detail, and its abstraction is through something called as a groceries list view. So that's the idea here. You are avoiding tightly coupled architecture and enhancing reusability by using protocols. That's a simple idea behind dependency inversion principle. Hope these 5 principles are clear for you guys. If you have any queries, or if you want to add something from your end which you understand better than what I understand about these principles, feel free to get back to me, because I am also willing to understand more about these principles and enhance my knowledge about these principles. So that's pretty much what I wanted to end with something which says, if you follow these solid principles judiciously, you can increase the quality of your code. Moreover, your component can become maintainable and reusable, both critical for a project's reusability. Let's say if you are in a product company and you already built a product and you want to actually reuse it in another product, then even it let's say your product is already built and your client is asking to actually enhance it with some new features. If it is very rigid, it's very difficult to actually do a maintenance work on it. So if you are actually following these solid principles, it becomes very easy to modularize your features and then extend it way further, even if you get new extension request or even a new modification request. So the mastering of this principle is not the last step to become a perfect developer. Actually, it's just the beginning. So there are so many other practices, patterns and practices which you can at least apply in software development. So this is not like the final thing that you have to learn to become the best developer in the world. This is something like a beginning where you will start becoming from an amateur developer to someone who can write a manageable and flexible code. So that's the whole idea here. So if you have to defeat these 3 enemies: fragility, immobility, and rigidity, and solid principle is your weapon of choice for that. So with that, I come to the end of this tutorial. Hope you enjoyed this one, and if you have any feedback on this, please get back to me. I'll try to comment or respond back to you as soon as possible. And like and subscribe to this channel and continue your support. Until the next episode, it's bye from me.